Okay, so relativity. Let's read the question. The Lorentz transformation equation for total relativistic energy states that, here's the equation. This can be simplified into this equation right here, where gamma equals this, right? So just to prove this, I know this might be a little bit basic, but it's fine. You can write this equation up here as, this, right? And as we can see here, gamma is equal to this coefficient, which is the same number here. So yes, you can write it like this. Right? Just I know that might be a little bit basic, but just to be clear. Okay, so basically the question is, with reference to the graph below and the equation for relativistic energy, explain why it is impossible for any particle with mass to achieve the speed of light. Now, this is a worded question, right? And when you have worded questions like this, just make sure to pay attention to the wording of the question. And we have to make sure that when we answer our question, we use this wording. For example, right here, any particle with mass, right? With mass. Now, that's important because if you think about this question, there is a particle that can achieve the speed of light, and that's a photon, right? A photon can achieve the speed of light, but a photon does not have mass, right? And you probably know this, so that's why it's worded that way. And we have to keep note of that because it can be important. Maybe not in this question, but in other questions, this wording can be very, very important. Our goal here is to use the words in this question in our answer, right? So we have to use the words in this question as part of our answer. So that's our main goal, right? Okay, so let's look at this. When you have worded questions like this, specifically with equations and things like that, what they're basically looking for is a series of statements where together all the statements prove what's being postulated here. So you can see the assumption here is it is impossible for any particle with mass to achieve the speed of light, or it's asking us to explain that. And what they actually want us to do here is to prove it with a series of statements where together every statement proves that it is true, right? And I know that might sound like it's a given, but it's not, because sometimes there are things that seem really obvious, like everyone already knows it, but you will be expected to put that in your answer because it is relevant, right? So everything that is relevant has to be put into our answer, which is why even though some of these questions might seem simple, they have a lot of marks allocated to them because they're looking for very specific points. So a way to think about questions like this is, what points should I include, right? So single sentences, or maybe just a little bit more than a sentence, just ideas, right? How many points do they want me to hit here? Well, we need to refer to the graph. We need to refer to this equation, and with both of these, we need to prove this statement, right? So where do we start? Well, we can start with beta here, right? Beta, and beta is equal to velocity over the speed of light, right? So what happens when velocity is speed of light? Let's see what happens, right? When we have a velocity that's the speed of light. Well, beta, which is v on c, becomes c on c, which becomes 1, right? And we can see here that when beta becomes 1, in other words, when the velocity is equal to the speed of light, suddenly there's something happens here on this graph, right? Gamma goes to infinity. There's a vertical asymptote here, right? So that's one thing that we might have to include in our answer. Let's look for something else. Okay, why does gamma go to infinity here? Well, let's look at the equation for gamma. This part of gamma, let me just write out gamma here. This part of gamma is the same as this, right? And just to be clear, this is the same as this, right? So if we have a v on c squared, the squared comes down to both of these values, so we can get this. So we can rewrite this as simply this, right? And we know v over c is equal to beta, so we can also rewrite this as beta squared, right? Hopefully that's clear. So in other words, this equation is equal to 1 over root 1 minus beta squared, right? And we know beta becomes 1 when velocity is equal to the speed of light. So if this becomes 1, it becomes 1 squared. So 1 minus 1 squared, which is equal to 0. And then this whole equation will become 1 over root 0. And yes, this does go to infinity. So now we know what happens. And obviously, you don't have to think of it as beta. You can just do it the long way as well. Velocity becomes c squared, cancels out 1. 1 minus 1 squared. Oh, sorry. 1 minus 1 is 0. 1 over root 0. Same answer, right? So when beta becomes, when velocity becomes the speed of light, beta is equal to 1. When beta is equal to 1, gamma goes to infinity. And we can see that on this graph here, right? We can see on the graph that gamma goes to infinity, and we can also prove it with the equation. So gamma goes to infinity. Okay, well then what? Let's try and include this last equation here, which we have not included yet. Okay, we know that gamma is just the coefficient of this equation, right? Just we can rewrite this as this. We can rewrite this, this here. We can rewrite it as this. So gamma is just a coefficient to this equation. Now, this equation is the total energy of a particle, right? This is it's the total energy of a particle. I'll actually just write here. Total energy of a particle equals this, which is equal to the rest energy of a particle plus the kinetic energy of a particle, right? So this equation is basically what it's telling us is this is the amount of energy that goes into the particle itself, but also in accelerating the particle to the speed it's at. So if a particle is at rest, its energy is just equal to this. But if it's in motion, it has a total energy, which is its rest plus its kinetic, which is this, right? E total is equal to this. So E total is an equation that's describing how much energy we need to accelerate our particle at a certain speed. And the speed is defined here in gamma. So we just realized that when our speed is equal to c, gamma becomes infinity, doesn't it? So if gamma is infinity and gamma is the coefficient to total energy, gamma is the coefficient to total energy, then this entire equation for total energy also goes to infinity, right? So just to recap, when velocity is equal to the speed of light, c, beta is equal to 1. When beta is equal to 1, gamma is equal to infinity. When gamma is equal to infinity, this equation, the total energy of a particle, is also equal to infinity. And what that's telling us, as we just saw there, is you require infinite energy in order to accelerate the particle to that speed. And that is impossible, right? So now we've proven it. Okay, so let's try and hit all of these points distinctively in our answer, because the marking key, the way it works is they look for specific points. They look for a series of specific points, and they make sure that you hit every single point. And the way you know what points to include and what points not to include is by checking, well, do all these points together prove what's being stated in the question, right? So you might have seen something similar like this if you've done a job aptitude test, right? Something like this. And now this is a really, really basic example, but basically the idea is which one of these statements together will prove that Sally likes ice cream. Well, what about these two? Well, no, they don't, because just because Sally likes Betty, it does not mean Sally likes ice cream, right? Just because Sally likes Betty and Betty likes ice cream, it doesn't mean Sally likes ice cream, right? What about these two, right? Well, Sally spends $10 every Sunday on things she likes, and Sally only spends money on ice cream. Well, yes, this proves that Sally likes ice cream, right? There's no other possibility here. She only spends money on ice cream, and she only spends $10 every Sunday on things she likes. So spends money on things she likes, and she only spends it on ice cream. So yes, she does like ice cream. So what we're looking for here, the idea that we have here, is very, very similar to that. And it's basically actually the exact same idea. So let's put some statements together that prove this, right? So what would our first point be? Well, as we saw, we can start with beta here. We can write when v is equal to c, in other words, when velocity is equal to the speed of light, beta is equal to 1. Okay, well, what does that mean? Well, this is one point. Second point, when beta is equal to 1, gamma is equal to infinity, right? Okay, that's our second point. Okay, third point. What does that mean? Well, when gamma, oops, when gamma is equal to infinity, E total is also equal to infinity. Okay, do these statements together prove that no particle with mass, remember, uh, here we go, with mass, right there. Do these statements together prove that no particle with mass can achieve the speed of light? Well, no. When v equals c, beta equals 1. When beta equals 1, gamma equals infinity. When gamma equals infinity, E total equals infinity. Okay, well, why does that prove? Why is this an issue? Well, why can't we have infinite energy? So it doesn't exactly prove it. We need one last thing to prove that this is the case, and that is that E total means that infinite energy is required to accelerate a particle to the speed of light, right? To the speed of light, which is c, right? So, okay, and one last thing we should do just to prove all of this, just to make it 100% clear, is infinite energy is impossible to obtain. So there we go. Now we've completely proven it. If you read everything here, the only conclusion that you can come to is that it is impossible for any particle with mass to achieve the speed of light, right? And actually, if you want to be extra careful, I mean, I don't think it matters in this question, but if you want to be extra careful as a general rule for every question, so notice that it does specify with mass here. So as a general rule, if you want to be extra careful, we have to use the words in the question. So infinite energy is required to accelerate a particle to c. We can actually be a little bit more specific here, and we can write infinite energy is required to accelerate a particle with mass to c. Right? So just making sure that we're being as clear as possible and using the words in the question. So it doesn't really matter here in this question, but for other questions, it could change the whole answer if you misread the question. So be very careful about things like this with the mass or specific wordings in the question, because it could completely change the answer. So these statements together, just like this, just like these two statements over here, these statements, all 5 of these statements together prove this. It is impossible for any particle with mass to achieve the speed of light. So therefore, we've proven it. We've explained why, right? And what they actually want us to do is prove it. So we've proven that it is impossible. So there you go. All right, cool.